So what we are going to look at it today. In today's session, we will review once again what is DAX is all about and why DAX is all about. And the Vertipaq engine, it is also called as X velocity now. And this is very much important in most of my students when they attended the interview. They were asked about the and how the Vertipaq engine works. Just give me a second. Somebody just now they are disturbing. Then we will take a look at the different types of operators that are available in DAX. Okay, now let's jump into understanding what is DAX. So all of the calculations we can carry out in Power BI, using DAX. So the Power BI are powered by DAX. Okay, and for example, you want to calculate the profit margin. So profit divided by sales, that can give you the profit margin, right? So if you want to perform any kind of calculations and if you want to reuse the calculations once you create a DAX function, right, it is possible. So DAX is nothing but the collection of functions, operators, and constants. It is also called as a query, DAX query. It is not only used in Power BI, it is used in Excel, Power Pivot, and SQL Server, SSAS, Tabular Edition, and Azure Analytical Services, and also DAX can only be used to filter or query a physical table. You cannot make any changes to the underlying physical table. Just remember that files or something like that. For example, you have say Excel file or CSV file, and whatever changes, whatever the calculations that you do it using DAX, you can, it will not impact your underlying physical file. For example, you have the sales column, you want to compute the profit margin, right? You want to create a column or you want to create a new column to make it part of your existing table. That is possible with the DAX, and you can also create a measure, but whatever the new column that you created, which is as part of the existing table in your Power BI desktop, you cannot, the new column will not get created in your physical file, the Excel file or CSV file. This is happening only in Power BI desktop in the memory. Okay. And why do I need to use DAX? As I mentioned about, we can use Power Query Editor, M language itself, but M language, it generates the M scripts on its own, right? We don't have to write anything explicitly, but with DAX, you can get most out of the data. So you can get most out of your data in order to, if you want to perform advanced analytics, that is possible with DAX, because it gives a lot of flexibility, a lot of options. And once you create a DAX formula, you can reuse it in you can reuse it, and you can use it in different places also. And you can create a complex or customized formulas. So it is always not straightforward calculations, right? In real-time scenario, it is not always we use the straightforward formulas like sum or average. That is not sufficient. We want to go over the board, and we want to perform analytics using different complex plus the calculations. In that kind of situation, the DAX is very much helpful. So this is the measure, how to create a measure. We'll start with understanding how to create a measure. Okay, simple measure or calculated column. So we will explain about what is the difference between calculated column and measure little later. At this moment, to start with the simple measure, how we can create it. So look here, this is the equation, right? This is the measure. So the left side of the equal sign, you can see the total says this is name of the measure, or we can call this a calculated column. Okay, either it should be a column or you can create a measure. These two things are different. The measure and calculated column, these two things are different. But supposing you create a calculated column with this formula, the total sales will become part of your table. A new column will be created as part of your existing table. But whereas measure, when you create a measure, it will not become part of your table. but it will be computed on the fly. Whenever you drag and drop the measure into your visual, it will be computed on the fly. That is the difference between the calculated column and measure. The equal sign indicates the start of the formula, and followed by the equal sign, you have the DAX function. In this case, the simple function sum is used. Sum of total sales. You need to use the open and closing parenthesis. Most of the beginners, they forget to mention either the open parenthesis or the close parenthesis. They start with open parenthesis, they mention sales, something like that. They forget to close this with the parenthesis. It will cause some, it will throw some error. Okay, make sure that whenever you use the DAX function, start with open parenthesis and you end with the closed parenthesis. And then the fifth one is the column references. So in your Power BI desktop, you might be using more than one table. How Power BI will get to know in which table this column is available. Sales is a column that is available as part of your financials table. You need to specify explicitly the table name. Followed by that, you need to specify, use the square bracket. The square bracket, you need to specify the column name. It is that much simple. I'll just go back to the Power BI desktop and I'll show you what we did yesterday. I go to the search here and total sales. This is my measure. I just click on it, look here. So the first one is my measure name. So in this case, I have created it as a measure. Okay, on the equal sign, and on the right side, sum of, you start with the parenthesis, open parenthesis, and close with the parenthesis. Inside of this, I mentioned about, in this table, you pick up this column and do the sum. Done. We are done with this. And either you can press enter so that it will get executed. In case of any error, for example, I forgot to specify the closed parenthesis. When I press enter, what will happen is it will throw an error. Okay, it puts, oh my God, okay. Let's say I intentionally put some typo or dot and all. Okay, you can see on the right side here. Here also you can see it, the error. If you have any mistakes, and you are not supposed to use dot and all here. It's a syntax error. Is incorrect. Okay, and you should be good with fixing these kind of issues. You need to identify where you made a mistake quickly, and you should be able to fix it. And then once I put this correct thing, and when I press enter, this one will disappear. There are no error in my script. It's good. Now we can see that we can use this script. So use this DAX measure. This is called measure. So you can see the calculator icon next to the measure. We don't see any error here. Good. So the next one is, can I see the value, that were computed on the right side, sum of total sales? Can I see the value? How can I see the value? The only way out is, if you want to see the value that got stored in this measure, you need to drag and drop it into visual, where visual can be a matrix visual. The moment when I selected this visual, you can see on the right side, just beneath the visualizations pane, the matrix visual got highlighted. Similarly, when you select this visual, you will get to know which visual. Look here, in this case, I have used the clustered column chart. Good. So far, so good. So the measures you cannot, as soon as, or once you create a measure, if you wanted to see the values, values of your measure, right? You can only when you drag and drop it in a visual, you can see it. You cannot see it. Otherwise, you cannot see it. And also, I just show you, is there any way I can create the same thing as part of my table itself? I want to create an additional column here. How do I do that? You can create a new column. When you click on the new column, that is called your calculated column. This is your calculated measure, and that is called your calculated. But once you create a calculated column, the new column, which will become a part of your table, You can create any number of columns. The more the number of columns you create, it consumes too much of memory, especially if your volume of the data is very high, very huge. It is not recommended to create so many columns unless it is really required. We will take a look at when we are supposed to create the calculated column, when we are supposed to create the measure in a little later. At this moment, we will jump in here and then we will take a look at the DAX engines. Now let us understand the mechanics of how the DAX formula is processed behind the scene by the DAX engine. The DAX engine is comprised of two components. One is the formula engine, other one is the storage engine. And these two engines work together to compress and encode our data and access our DAX queries. So now we will explore the role of formula engine and storage engine. The formula engine is responsible for accepting the DAX query. So this is the DAX query I created. This is what my DAX query. As a developer, I just created a measure. This is a requirement from this is one of the requirements in my project. I created it. I just dragged and dropped it. The moment when you drag and drop it, what happens is the formula engine will accept your DAX query, and then it will process your query. In case of any syntax error, anything is there. Okay, nothing is there. Then what? And then next step is it processes the query and generates the query plan. Something like Google Map. Okay, so it generates the query plan. In the import connection mode, right? The formula engine sends a data request to your storage engine. Okay, because the formula engine cannot retrieve the data directly from your data set. Okay, upon receiving the query plan from the formula engine, what this storage engine does is it returns the Vertipaq. It is now called as a X velocity data cache back to your formula engine. The formula engine, upon receiving the data cache, it will populate, it will return the computed output in your visual. So now the question is, okay, in the case of import, only in the case of import connectivity mode, the Vertipaq kicks in. Okay, this one comes into picture. It converts your tabular data, Excel file, which you have loaded the Excel file or the CSV files or a JSON files. What it does is the Vertipaq, which is nothing but the X velocity. This is the new name. Okay, forget about Vertipaq. So henceforth, it should be called as X velocity. So the X velocity, it does the four tasks. The one is it converts the data into from tabular to columnar. It converts the tabular data into columnar data. Okay, and the second task, what it does is it encodes the data. It encodes the data. The third step, what it does is it compresses the data. It compresses the data and load it in memory. It's something like if I ask your dad's father's contact number, you can tell instantly because it is there in memory. And if I ask you your maid's phone number, you have to go and search in your mobile phone, right? So anything which is in memory, it is faster. This is the role played by X velocity engine. What it does is upon receiving the request from the formula engine in the form of query plan, the storage engine send that query plan to your Vertipaq, and then in the case of import connectivity mode, the Vertipaq or X velocity kicks in behind the scene, and then it performs these four tasks. If it is in memory, anything it is memory, it is faster. That too, it compresses data and loads the data in memory. For example, your data file size is 1 GB. Okay, but when it loaded into your Power BI memory, right? It will get compressed 10 times lesser than this file size. The file size will become will get compressed, 10 times lesser size of than this one. So let's say your 10 MB it will be there. Okay. So the original files is 1 GB. After it does the compression, it will be very small. And then this loading this data into memory, it will not take much time, and it will not consume too much of memory also. That is the beauty of X velocity. That's why Microsoft recommends use import connectivity mode, because the performance pretty fast. But again, on a case-to-case basis, we need to decide whether we can go for import or the direct query connectivity mode. Direct query is advisable. The volume of the data is very, very huge. And if the data is already available in your SQL server or any other RDBMS system, you can leverage the RDBMS system's functionality. So you don't have to pull the data and you don't have to load it into memory. It takes time. Okay. Okay. In the case of direct connectivity mode, let's say you connected to, you created, in this case, what happened? The total sales, sum of sales, we did it, right? So the sales column is available in my SQL server. In the case of direct connection mode, the formula engine, it sends a SQL query directly to your SQL Server database. This is your SQL Server database. It sends the request directly to your SQL source database, and this is the data back from the source database. Okay. So for in-memory models, the imported and column or memory cache is the storage engine. Okay, that is what the storage engine. So this is how it works. It reads the data source, transforms the data into columnar structure, and encodes and compresses the data within each of the columns, and then it writes, and then these are the 4 tasks performed by X velocity in the case of import mode. Okay. Now we will understand, when I discussed about the Vertipaq or the X velocity, it performs 4 tasks. One is, first, it convert your tabular data into columnar data. So why it has to convert the tabular data into columnar data? First, let us understand that one. This is your row store and this is your column store. Let's say you stored a data in a table. The data is available in a table. And if you access the table as it is from the row store, what will happen is, supposing you have 100 columns are there in your data set. What happens is, it goes and look at each and every column. Of these 100 columns, you don't need all these 100 columns for your thing. Let's say you wanted to see the category, sales by category. Okay, in that case, you need only these 2 columns. But even though you have used these 2 columns in your DAX query, what happens is, each and every column behind the scene, in the case of row store, it goes and check, is this the column is category? No. And then it skip. First column, it goes and check. No, this is not category. Okay, second column, it goes and checks. And until it finds the category column and sales column, it has to keep skip, and it has to go and check whether this column, whether the existing column is same as these 2 columns or not. Until it finds these 2 columns, it has to go and search it. That will take longer time, especially when you work with millions and millions of records. It takes a lot of time. Instead, you store each column separately. That is what your columnar database. So in that case, what happens is, behind the scene, right? So all you need is just, you want to view, select the data only from these 2 columns. Since these 2 columns are stored separately, this is your, for example, instead of category, your product name and the unit price. All you need is the product name for the camcorder and smartphone unit price. It goes directly to these 2 columns, and then it selects only, it subsets, right? It takes only these 2 columns that are required for your analysis directly. Instead of going and checking in each and every column, is this a name, product name? No. And then go and check, yes, product name. Is this unit price? No. Then you skip it, go and check it. That is how it is happening in the case of row store, whereas in the case of column store, since the columns are stored separately, not part of a table, so what will happen is, it goes directly to the columns, relevant columns, and then it takes the records, whatever you needed. Hence, it is faster. So that is the reason why it converts your tabular data into columnar databases. Simply said, the columnar databases are more CPU exhaustive, whereas the row store database increases I/O because of many scans of useless data. It has to scan and see each and every column. With the columnar databases, single column access is fast and effective. So once the computation starts to involve multiple columns, things become more complex. Okay, so that and all we'll see later, but you understood why it is converting from tabular to columnar database. And then what it does is it does the encoding and compression, which one? The X velocity engine. So what algorithm it uses to do the compression, right? It uses something called encoding. The objective of compression encoding is to reduce the amount of memory that is required to process your query. Okay, and the Vertipaq stores a compressed copy of the database in memory, and compressed columns make your code and query runs faster. Okay, when you have compressed data, the performance will be faster, right? So now we will understand what exactly encoding is all about. Okay, in order to do the compression, it uses some technique called encoding. There are three types of encoding. One is value encoding, other one is dictionary encoding, and the last one is run length encoding. These are all very simple, easy to understand. In case of any integer values in your column, in your table data set, you have any integer values, then the value encoding comes into picture. The value encoding compression technique is used. So it converts a lot of values in Power BI to integers. And the next one is the dictionary encoding. This is for text type of data. And run length encoding is used to look for repeating values. We'll directly jump into each and every type of technique and understand how it works. It's a very interesting one. Look here. In this case, in the case of value encoding, as I told you earlier, so it is used on integer value. This is an integer value. Okay, and this is my original data here. What happens is the value encoding, it transforms this value into this form. If you look at here, almost all the digits are 2 digits, but few values are in single digit. It converted the 3 digit into 2 digit or single digit. How it is possible? What happens here is it takes the minimum value. What is the minimum value in this data set? 194. It's subtracting 194 from each and every value. So 212 minus 194, 18. So if you add 18, what will happen? 212, correct. And 197 minus 194, 3. Likewise, it takes the minimum value from your original column and then subtract the minimum value from each and every value. So this way, what happens is you get, in this case, what happens, the range of the values are, the 0 to 22. So whereas here the range, if you see 194 to, what is the maximum value? 216. So in this case, the X velocity discovered that by subtracting the minimum value, which is nothing but the 194 from all the values of the column, so it could modify the range of the column, right? Reducing it to a range from 0 to 22. Storing numbers up to 22 requires less bits than storing numbers up to 216. So you might be thinking just 216, here 8 bits needed to store the 3 digits, whereas here 2 digits, just 5 bits are needed. You might be thinking 3 bits, how does it make some, how does it, makes so much of difference in terms of performance? Obviously, when you are using billions of rows, right? If you multiply, when you multiply this value, right? 3 bits you saved, right? So 3 bits into few billion records, you can see the difference, right? It will consume less number of storage. It doesn't require too much of space in your hard disk, right? It reduces the space. Using value encoding, this is how the value encoding technique works. This is to reduce the size of the data. Okay. The next one is the hash encoding technique. So the hash encoding, what happens is behind the scene, It works for the text data. Behind the scene, it builds the dictionary. So this is what your original column. In your original column, you have something called different colors are there. What happens is it builds a dictionary, something like this. It assigns some value, okay, for integer value for each color. So what are the unique values here? So you have a lot of values, but how many red? So how many unique values are there? So red, white, and blue, and black. Only 4 unique values are there. For each unique value, it assigns some value. And then what happens is beautiful thing, right? So it replaces all these values with 0, 1, 2, 3. Wherever red is there, it replaces red by 0. And wherever white is, replaced. So this way, it reduces the space. It replaces the columns value with the integer numbers, where each number is the dictionary index of the original value. If it refers this one, right? So 0 is nothing but red, it will pick up, it can understand. By creating a dictionary, it uses the ID or index value. It replaces the index value for your original column, okay, original column values. And the next one is run length encoding. This is actually pretty straightforward, but it becomes really powerful when it is combined with another type of encoding. Look here, this is my quarter column. So here we have a lot of values are repeated. Q1, Q1, Q1 repeated, and Q2, Q2 repeated. Almost 310 times repeated. And in this case, the Q2 repeated, or 290 times it occurs. The number of occurrence of Q2 is 290 times. Similarly, here it is 310 times. So here, you're also kind of a dictionary. Look here instead of having, right? So for this, they create some kind of dictionary here. The quarter and start and count. In Q1, the quarter value starts from 1. And how many number of occurrences of quarter Q1 is there? 310. Push here. Similarly, in Q2, it starts from 311. Because in Q1, Q1 is appearing 310 times, which means the first value of Q1 is 1, right? And the Q2 is 311, and the count is 290 times. Okay, the next step is it creates both the dictionary as well as the repeated values. The Q1, Q2, Q3. So how many values are there uniquely? So per year, we have only 4 quarters, Q1, Q2, Q3, Q4. For that, it creates some kind of ID here, index value 0, 1, 2, 3. And then the repeating values, what it does is for 0, it repeats 310 times. Now it created a dictionary first, okay, and then what happens? Run length encoding. Right? It's combination of these two, hybrid of dictionary encoding as well as the repeated values. All the Q1, okay, here the Q1 count. Look here. In this case, 0 is nothing but my Q1, and then the 310 number of occurrences of 310. So 1 is 290 and 2 is 490, 425, and 3 is 350. If you look at this data set here, the Q1, all the Q1s are replaced by 0, 0, 0, and Q2s are replaced by 1, 1, and Q3s are 2, 2, 2, and Q4s are 3, 3, 3. Okay, right. So in this case 4, okay, it should be 3 here. Okay. Now what happens is here, since it created the dictionary, the index value for this one, right? 0, how many number of times it occurs? Okay, so in this case, it has to go and do a lookup here, and then this one will do a lookup here, how many number of times it retrieves. So in this case, only 4 values, right? 0, 1, 2, 3, 4, 2 bits used. It saves a lot of space. This is how it does the compression. For the integer values, it uses value encoding. For text, it uses hash encoding. And some cases, right, it uses run length encoding. In the case of more number of repeated values, that kind of RL is used. Okay, to summarize, the DAX uses 2 engines, the formula engine and the storage engine. The formula engine interprets and evaluates the DAX, and the storage engine, this is where the storage engine only, the compression, all the things are happening, right? The encoding, all things, it is happening here. And there are 2 types of storage engine. Within the storage engine, there are 2 types. One is X velocity and direct query. In the case of import mode, X velocity engine will kicks in, And then in the case of direct query, X velocity will not comes into picture. The formula engine will send the query plan directly to the SQL server or your RDBMS source system, and then that source system will send the data back to your formula engine. So DAX is a two engines, formula engine, storage engine, and storage engine. It uses two types. One is the X velocity, that is for import. This is a direct query. Okay, and Vertipaq stores data using columnar database setup. That is what I explained to you. The data is stored in individual columns so that it can be accessed quickly in the case of a columnar database. But queries that call multiple columns may require complex logic to produce a data cache. And raw data is compressed and encoded to optimize processing. Okay, so we have seen how the compression works, right? With different types of encoding, it does it. The data can be compressed using value encoding, hash encoding, or run length encoding. And the overall compression of a column is determined by four factors: the cardinality, which means the number of repeated values, row count, and the data type. If the data type is integer, it uses value encoding. Text, in that case, it uses which one? The hash encoding. In the case of repeated values, right? No, number of occurrences more, that kind of situation, it uses run length encoding. Repeat values, number of repeat values. So based on these three factors, it decides what kind of encoding it should be used. Got it?